Of course, you know I'm going to simplify this particular content. I mean, this particular video tutorials. But there's no way I will start off this particular video without thanking you. I'm talking about you. You that always come to this particular channel. You don't leave without hitting the like button. You don't leave without sharing my video. You don't leave without doing all of those necessary things that will help me grow my channel. Thank you so much for your regular support. So let's get into the video. If you're a new person who is just joining, please consider hitting the subscribe button, turn on the bell icon so that whenever I upload new video, you receive notification. Let's get started. We're asked to find the total capacitance in this particular, amongst these capacitors. You can see this is a capacitor connected randomly on this particular circuit. So people always struggle with circuit problem, but I'm going to dissolve this particular right now. Let's get into it. Now, I want to label these things. Look at point A to B. We have a lot of capacitor. Let's label it. This should be C1. Let's make this one C2. This should be C3 and this C4. Why am I labeling these things with C1, C2, C3, C4 respectively? It is just for reference purposes. There's no special thing about them. So if I say C2 and C3 are connected in so stuff, it makes sense, isn't it? Why are you doing like this? It makes a lot of sense, isn't it? Okay, that's good. So let's get into it. So you can see from all of this, we can't tell what this and this is, whether they are connected in series or parallel, but we are certain about this particular one in the middle, in the center, that C2 and C2, capacitor C2, and capacitor 2 and capacitor 3, that is C2, C3, are connected in series. This is serial connection. If I hold this particular guy like this, and I turn it like this, it will be in this form. So you agree with me that this is a serial connection. This particular C2 is this one you're seeing. This C3 is this one. What is the value for this? Is 7 microfarad, and this one is 5 microfarad. So this is what we call serial connection. Serial connection has a formula. When you're dealing with capacitor connected in series and parallel, there are two formulas you need to be familiar with. Capacitors in series formula and that of parallel. We have a lot of formulas on that capacitor, keep in mind. So what do we need to do in this case? Let's apply the formula first of all. Sometimes you may see me doing some tricky stuff because I want to find the equivalent capacitance, the equivalent capacitance of the capacitors connected in series. I will just do something like this: 7 times 5 divided by 5 plus 2. 5 plus 7 rather, 5 plus 7. And this will give me 35 divided by 12. And of course, if you divide that, it should give you by 2.9166, or maybe approximately microfarad. Now, keep in mind that all these things are operated on the same, operating on the same unit. They're operating on the same unit, microfarad. This guy stands for micro, and this is farad, microfarad. All right. So since they are all in microfarad, there's no point we converting, doing any form of conversions. Just leave it. Your final answer will also be in microfarad. Keep that in mind. All right, this is the way I would have done it, but a lot of students don't know the particular formula I applied to get this done. Let me show you real quick. So capacitor connected in series has a formula: 1 over equivalent capacitance, or total capacitance equivalent. EQ stands for equivalence, is equal to 1 over C2 plus 1 over C3. This is it. So then how does it look like this particular one? It's pretty simple. You can do a shortcut. If you like, you can collect like terms. For those of you who like collect, let me show you two methods. One, I will clean this thing after now, so pay attention first before you write. The LCM of C2 and C3 is C2, C3. C2 divided by C2 will give us 1. It will go off. So C3 remaining, or this and this can cancel out. Better still, C3 times 1 will give you C3 plus C3 will cancel out with this C3. What will be left is C2. C2 times 1 will give us C2. Now, this does not look exactly like this because we are looking for C equivalent and not the inverse. So if you're looking for this guy, now take this up and bring 1 down. That's how you take this up and bring it down. So you have C equivalent divided by 1, which is C equivalent, equal to, this goes up, C2 times C3, or C2 C3 divided by C3 plus C2. Now let's go over to this part. What is your C2? Look at your C2, 7. You can see 7 times, what is your C3? C3 is 5. This is the 5. Divided by C3, this is your C3, 5, which is this. C2 is 7, which is this. You can see that shortcut. So that means you need to be familiar with formulas for you to be able to do this. If you don't want to go to the length of looking for LCM just like I did right now, let me take this off. If you've not copied this, please go back. Just go back a little and copy this. If you don't want to do LCM of a thing, I want to use shortcut. Let me teach you that real quick. C equivalent is equal to this times this. C3 times 1 will give us C3 plus C2 times 1 will give us C2 divided by C2 times C3 will give you C2 times C3 or C2 C3. Now you can reverse this, you can flip it, you can turn it upside down just for you to get C equivalent. And that will give us C equivalent equal to C2 times C3 over C3 times, plus C2. You can see that that will still give you the same thing. I hope you're learning. I hope you're learning. Please consider to hit the subscribe button and share this video. Like the video first before we finish. We are done with this serial connection. Now, the interesting part of it is this. I want to take my time to make sure that you understand every bit of thing I'm doing right here. Now, remember, I resolved this to give me this particular one. That means I just have a single capacitor like this, which is this 2.92 microfarad. Can we clean this off? Because it was these two guys that I resolved to get this single guy rather. Now look at it. Look at it. If I decide to carry this guy and replace this guy, it means I have to clean off this guy. I have to clean up this guy. I'm showing you practical stuff that will make you understand this. Then this guy, I want to replace it here. So this line is supposedly, we have it to be this line. So this guy now, this capacitor comes in between here. We have it like this. And then you have the value. That's the single guy you have it. Now you can see we have a single guy here. We have single here. This line, look at it. Look at what I want to do. This line, if I expand it, if I expand this guy, I'll be having it like this. That will be this 6 microfarad. Again, this 1 microfarad, if I hold this one and expand it, that will be this guy, which is the 1 microfarad. What about this AB? Look at it. Look at the extension. This is point A and this is point B. So this guy is this one is this one, and this one is this one. That is how simple this could be. So this is your C4. This is one you calculated, which is the C equivalent. If you want to put it that way, this one is your C1. Now you can see that these ones are connected in parallel. This was in series. I resolved it. The whole of them now, they are in parallel. So you need to use the parallel connection formula to solve for this particular one. How do you do that? Either use, since we have gotten the C equivalent, let me use something C total, because you have to find the total capacitor. C total will be equal to C1 for this particular one, plus C equivalent. If we had made it C2, that would have been C2 plus this one C4. So C total will be, what are the values? This one will be 1 plus, don't bother about the units, they are all having the same unit, so we'll just put the unit after the whole answer. Then this one will be 2.92 plus this one will be 6. So C total will be equal to, you need to add up everything you're having here. Remember, the whole of these are operating on the same unit, microfarad. 1 plus 6 will give us 7. So what is 7 plus this? 7 plus 2.92. That is giving us 9.92. 9.92. 9.92 microfarad. This is the total capacitance of these capacitors connected in this particular circuit. And I hope this particular video tutorial is explicit. I hope it is helpful. If you know for real this is helpful, please leave a comment in the comment section. Don't just leave without dropping a very nice comment. And don't forget to share this particular video. Don't forget to hit the like button. That will allow me to do more of this. If I see that you guys engaged on this massively, I will do more content on this. If you want to join our section, we are available. If you're preparing for GCSE exams, you're working on any particular AP physics, AP calculus, you're dealing with maybe A-level mathematics, A-level physics, A-level chemistry, you're dealing with any form of exam like JUPEP exams or JAM exams or WAEC exams, you're dealing with all kinds of exams in the college in year 1, year 2, year 3, and you need somebody who is going to help you on these particular things, we are available. Reach out.